Hi guys, hope you're having a nice day. In this video, I'm going to build a small simple RAG application. Before that, I want you to guys understand what is RAG. RAG is retrieval augment generation, which is like giving an external knowledge to your LLM. I'm not going to explain about RAG in this video. In theory wise, okay. We are going to build an application. My plan is to build one nice tool. In the recent days, there is many technologies and many frameworks was available in market, right? We can't be a hero in all the part. So, what my plan is to build a tool that extract that newly available framework in a market that we are going to extract it and store it in document, and we are going to interact with that using an LLM. Why I'm building this is when it is recently launched, the LLM not giving a right code. Okay, so because even that is search in a website which is not trained with that framework, so it is not giving you a right information. So I'm going. That is why I was building this. I will show you my outputs. What tool we're going to build. Then we start our work. See, this is our application, guys. First, we this is our web scraping tool. Okay, what we're going to do is we are going to some framework. Okay, this is Microsoft Agent framework. Okay, actually, this tool is recently launched, guys. Okay, we don't want a quick this. We start with create and run agent. Okay, because I'm going to extract only 10 pages here. Okay, so we start with this, and I want a Python language, so I've chosen that and copy this URL, and I've been pasting it here. Okay, and start scrapping. It started scrapping, so it will, with the backend process, is go to this page, scrap everything, and click on this next box, and it go and look on other things, and it go like that until it reach 10 pages. Okay, so we scrapped 10 pages, and file is saved in output folder name Microsoft com. Okay, learn Microsoft com. Now second step is indexing. So what we do here is we can drag and drop any file here, or else the scrapped file will list out here. We can select that file and run index selected file, and 271 document chunks are created and chunked. Okay, that was count. The metadata have not added anything, and the code generation. Now we are going to ask a question. Create a agent, weather agent. We create weather agent tool. First we create weather a tool agent tool, and connect it with the agent. Give me a single file code to run this project. Okay, this is not going to give you an build a project, guys. This only generate a code for you. 8 number of source of document, 5 up to it is allowed, and we are generating our code right now. Okay, this is using .NET, but we want in Python, guys. So which is created. Here is there a function, and here we are creating an weather agent where we passing this weather uh, tool, and there is a main agent where this weather agent is act as a tool, and we have ASIC define and where we have question and there is an answer. Okay, and async.io which is there. Okay, we run this file and see what is happening. Okay, test. Okay, where I create one file named agent demo.py. We paste our code here. Actually, for running this, we need an agent framework should be installed and an Azure credential you needed. I don't have Azure credential, guys, so I'm using this OpenAI OpenAI chat client. So why this is giving in Azure? Because the document is fully covered only with the Azure OpenAI chat client, guys. So why it is always returning you that code? Okay, it is fully covered with the Azure OpenAI chat client. So why it is like that? But I don't have the credential, so we change. OpenAI chat client model. And for OpenAI chat client, you guys need an API key. I have stored in environment. So once you guys running that, please make sure to add that env in your terminal, and we run this file and we see is it working good, which is in test folder, right? Yeah, and Python agent demo.py. Hope it running well. No, there is an error. Open API key is required. Set API key. Okay, I have not set it properly. I think I set it now. I have set that API key in terminal. So now I'll run this application, run this and see if it is working or not. Okay. It's throwing some error, but we look out. Actually, look, that is integrated. That answer you got. Okay, this is in some language, some other language. I don't know what is that. We look. There is a copilot here. Translate to English. No translation available. There is a copilot here. Weather in Amsterdam is sunny with a temperature of 75 degree. Would you like more information about the weather? Actually, you get the answer here, right? But you are getting some error which is not related to the agent. The error is happening because of you running an async io dot run. Uh, in Windows, you have to set up something to run this. Okay, so why we are getting this error? There is no problem with running this agent. We got the answer. Why there is a 45 degree? Because the get weather tool doesn't do anything. It's just returning 75 degree. Okay, that's it. It's working perfectly. Okay. I have already shown you how my application was running. Now I'm going to create the same agent, same prompt. I'm going to give the same prompt to ChatGPT and wait and see what is the response it is giving. Create a weather agent tool and connect with an agent using Microsoft Agent Framework in Python. It's thinking. Wait. Look, guys, it is using Microsoft Bot Framework SDK. Okay. And it is using Flask to build our application. Look, which is not even used agent framework package. Okay. So this is the main issue, guys. So why we have created this application. Now we go and look our application. Okay, guys, I'm not going to build scrap by scrap. Okay, actually I am building an application using a cursor only, so we are not going to build it from uh, typing line by line in cursor. We're going to use this agent plan, everything to build our application. I have created everything, and I have configured everything, uh, tested everything properly. So I'm going to explain this code to you guys. Okay, first thing is, when you load the page, navigation would start from web scraping. So the screen you are viewing is built in by Streamlit, which is one framework um, to build an UI application, UI thing in Python itself. This is quite good one. I'm really love that Streamlit too. So we have set our page config, where I have added a title and icon and layout. So here you guys see, this is our this step we finished. So first thing would happen here is main. We set our title and we have our markdown, and we have our navigation bar. I have set three things here. When we click our page as a web scraping, here look, we set this and we have set these. When we click this, what would happen? Now the header web scraping was display, and there is a markdown. Extract documentation from website and save the docx file. Web scraping and this two part was done. So what next? We have a two column. Yeah, see, yeah, we have a two column, where one column we have set a URL box, and another column we have set a select box, right? So one is a text input, another was a number input, which has minimum one value. It is essential, and value is 10, greater up to we have can raise it to 100. Okay, we can raise up to 100, but 10 is fine now for now. And we have a start scrapping button here. So once you enter, you click this button. Once you click that, the scrapping work will start. So we trigger a function here, right? So when you click a button here, scrap and save. Okay, what this do? This is a function called, we go inside this in Streamlit app that by itself. I zoom little bit, guys. Now the agent screen is not needed. I minimize it. I hope this is more clear, and we close our terminal too. We first scrap and save the content. Here we scrap and save the to docx. Okay. First the spinner will load. When you click here, when you click here, the spinner first load. Okay, so and the scrapper web scraper got initialized, which is a class we used for web scraping. So here is our data structure, project structure. In this folder, the scrapping part was there, and here was the indexing part and code generation was a rack part here. First, we go to scrap. I'm not going to explain more about scrap, guys. Which this video is about rack. So first, I'm initializing. Have created a section, and I'm storing this and visited URLs while we are navigating up to many pages we navigate. So we are tracking our visited URL and the delay time, everything. And here we storing our scrapped content. This while creating, while initializing, while you create a object which are the init part. This is a constructor, so it get execute, and we store all the values in this variables. Now we are calling the scrap website method. We are going inside now. So this is a start URL. Max pages I set up to 10. So now we are going. We have set our visited URL and scrapped content. Nothing is there. We have set current URL as a start URL, and the we have printing our content and pages. I hope it, I guys, I can see you or show you that. Okay. Okay, this is our output screen. Okay, started scrap from our link. Okay, this one is printed, and while current URL, uh, we have to take up to 10 pages, so we are checking our conditions here, which is we have only checked the 10 pages. Next thing is we are started our scrap content here. Scrap page, we go inside this method and see what is happening. In web def scrap page, what we are doing is we initializing our beautiful zoo and started extracting text content. Okay, where we extract our title. This is our one metadata, and a heading. I'm extracting the heading. uh, all heading in that page. We think we are moving in page now. Okay, I will show you in drawing. Okay, first this is our document. Okay, where we have first page, and this is our second page, and this is our third page, and this is our fourth page. Okay, this we what we taking is we are first we taking this one page. Okay, now we have I have taking a metadata. What I was taking is I was taking a title and the header. What next I'm taking a para. I was taking a Paragraph. I'm taking a paragraph now. Next is very important thing, that is our code snippet. Okay, code snippet. Okay, these four are our main target we are taking from our uh, web pages. Okay, so what next? We scrapped our page, and now the page data we have adding into our scrapped data. Okay, this in init file we have before initialized this. Okay, the scrapped data where we are adding that now in the scrapping website part. Once we added that. Okay, once we scrapped that, we are adding our data to scrapped content, and we are increasing our page count. So next is we have to find the next URL. Okay, first we are saving our current URL in the session, and we are setting the timeout. And to find a next page, we are having this function which is navigating as our web scraper as before. So these is the only pattern I'm identifying. If it is in more pages, you can see there was a next and previous button in most of the documents. So I have added next patterns would be like this, and previous patterns would be like this. So we are finding all the anchor tag with this pattern. If some files there would be the next tag is present in anchor tab. Some where it is present in div. Okay, I'm saying like the next anchor tag, anchor hyperlink would be present in anchor tag only, but the div element class has a name of next. Okay, not that anchor tag. So I am adding that as well. So I have added all the anchor tags, and I'm getting the full URL. The next URL would be it will show it there, the link would be slash and the last part, right? I mean, so when you click the next button, you can see that these images only changed. Okay, remaining part was same, so we are setting that here. Now, so once you get that new URL here, it is returning back to our scrap website in web scrapper. Okay, so here we have get our next URL. We set our next URL as a current URL, and this function call would start again until the 10 is completed. Okay, we have set our sleep time here as uh, some delays we have set. We have set these configuration in our config.py file. Here is a file. Okay, here I have loaded the load.env and open API key details, Chroma DB path, and collection name. I have set it as document, and chunk size and scrapper delays was 1.0 second. Okay, max pages allowed us up to 100. I have set all the default configuration that is needed. I have set it here. Output path would be output folder where you have to create a docx file and we have to store there. So here we creating our files too. Okay, folders too, these two folders. So once you scrap the content, what next? If there is no content, no content scrapped would be displayed, or else we are saving that in this file, in this folder. Here we are storing in this folder. Here is a docx writer. This part, uh, here we have another file named docx, right? So this file have a method. This class have a method of create document and add page to document, and everything related to saving documents are present here. Okay, now I'm creating a new document, so that I have added a title here and paragraph alignment. Add paragraphs and timestamp when it is created. Okay, why I have so many things here, right? I will show you why it does so many things here. Okay, this is our output docx file. Okay, guys, so when you open this, you can see this content. We have mentioned that here is our documentation, and the page link was here. When it is created, it is created on 25/12/7 today date, and the total page scrapped was 10. So when you scroll down page 1, the URL link, the title, scrapped time, and share, these are the headers there, and these are the paragraphs that present in there, and below is our code snippet. And when you scroll down little bit, last and final, we are having our full context. Okay, without dividing everything, we have adding our full content. When you scroll down a little bit, the page to start. Okay, so we have a pattern to store our data, so this is needed. Because of that, this is needed. Creation time have said. Now it's time to add paragraph. So add page content function is there. Okay, this is what to add a, first we create a document in this. It will initialize this function again, and we have adding our page number as we seen before, and URL, title, and we scrapped the time, and we are adding our paragraph and the heading and the type, and last we have adding our paragraph. This is part our for our code block. Okay, we are adding our code block, and then next add full text if available. Okay, and we are adding our full extracted text in this area, and finally we are saving our document. If there is no document, error will throw, and we are adding our docx as an end of the file name, and here we are creating a directory file path, and we have saving the file. Okay, right from scrapped content. Okay, so we are having our scrapped content, right? Yeah, we have before already I have mentioned what are the paragraph, what are the patterns was there, the format in this method we call that function everything, and we save our document. Okay, so when you go to streamlit app.py, we call that last method as I said before. Before I have mentioned as a save document, the add page pattern, and create document method, right? That are all called here. Okay, first we create our document and add a paragraph, and we add a page content and everything, and we save. Okay, Right. We have the scrapping part was now completed. So what next? When you scroll down, return to the main function, the scrapping part was done, and there is a button. These are all the stuffs to list showing. Look here, we having showing the path of the file in a column 1 and column 2 manner, and we are having a download button at the right side. Okay, look here, this is the first column, this one is the second column. Here we list out the document that is scrapped, and here we have a button to download that. Okay, so that part is have here. Okay, the first column is to show the file name, and second column is to show the kb, how much was a storage of that extracted content, and the third column we are showing our download button. Okay, that's it. So first page was done here. Okay, web scrap page. So the second one in navigation bar is document indexing. Okay, you scroll a little bit, you can see document indexing. Okay, if you click that file, what happened, it says the header, we have document indexing load docx file into the vector store, initialize rag. Okay, I will show you that. Before that, we click this button and see what we have a header, and we have a markdown, and we have a header again, and there is a drag and drop button, and index existing file we have something, and here it shows the extracted content. Okay, now there is a button to index selected file. What it is do, I'll show you that. And the vector store information we are showing here. Once, if you want to clear a vector and do another website scrapping, you can clear the vector store here and start the scrapping again. Okay, so I will show you guys now in code. First, here in this part, this is about drag. Okay, scrapping part was done, we come to the main part, that is initializing drag. So this function is still in streamlit app.py file. Okay, first I am checking that open API key is set in environment variable, or else it show you an error message in streamlit view itself. And then we are setting our vector store. Okay, this is our first part. Okay, we have creating our object of vector store. We go to this file. What this is do? Okay, first I say what is this vector store. Vector, this is a vector db. Okay, this is our vector db. What we create using for vector db is chroma. Chroma db we are using. Okay, which is really useful if you want to build and store our embeddings in our local, then we can use that. Okay, first what I'm doing in vector store is, for creating a chroma we need a path, right? We need a path. First here you can see there is a folder named chroma db, which is created after this only. Okay, once you're running the project first time, on the time this chroma db will create. Then there is a file named chroma sqlite 3. This is our Chroma DB content. Okay. So what we doing is, it is like other PostgreSQL, MySQL content. Okay. So you should have a database name in PostgreSQL like that. Here you have a collection name. Okay. Where here, which is a document. Okay. Now we have a persistent directory there, that path of this Chroma DB location. Okay. So here is a whiteboard. What we need next is our path, that is path of Chroma DB. So what we need next is OpenAI embedding. Actually, embedding is like once you extract a content from a page. Okay, one page. I'm not saying about web page here. Parawise you may extract. There is many strategies to how to extract data, how to chunk it. Okay, consider if you chunking it by para. So now you got para. Right now, what is the next thing is, you have to convert that into embedding. Means that is a numerical representation of the words. Okay, and we have another variable name client, where our Chroma DB client was initialized. Here there is no track of what is happening. Okay, so I have changed it to false, and we have our vector store is none, and initialize our vector store. Here nothing, we just create our folder and we create our DB, and it is ready for our embedding storing process. Okay, the embedding was set here and everything was done. Okay, and now the DB is ready once you initialize a vector store. So what is next? The code generator part. So there is two more files to see. This is a code generator class. What we do here is, we have initializing our chatbot here. Open a chat OpenAI here, and I'm giving a strict rule that prompting here. I'm saying that you are a software developer, you have to generate the code, and you have to analyze the document carefully, clean the content, give me good pattern, function, everything was looking good. Like that, I have said the prompting. Then this is a retrieval RAG pipeline. Okay, so what it do is, it find you 5 relevant chunks, and these link to that 5 chunks are linked together in same together. Okay, that is a chain type stuff too, and we are just initializing our QH chain here. We are not using it here, and the initializing part of code generator was done. So once you went to that page, the initializing part was done. Okay, so what next? No, we scroll down and look. So this is a part we have initialized. If initialized, we have stopping that. Now there is a box to drag and upload that is here, and upload file is not none. We have to find this output file and have to show the list here, right? So these are the file uploaded content, and there is a button named index document. Actually, this is for here, okay? Once you browse, when you add a file here and when you click a browse, the index button will create here. This index selected button is appear later, okay? Here is a vector store information. Sorry, here this is what here, index selected box, okay? And we have an index selected file here, okay? Here is a function named index doc file. What it is doing, this is doing our actual operation, guys. We are initializing rag first. If not that executed, we initialize and the thing was started. First thing was we load our document. So our third file, document loader, getting initialized here. Okay, document loader is like first thing in our rack, which is known as first part is chunking. There is a chunk size I have mentioned in config file as 100, I think. We have mentioned our chunk size as 1000 and overlap as 200, so it comes here. So what is this chunk size and the chunk overlap is means? I will show you. Okay, guys. So look, this is one chunk, okay, which consider it has 1000 character, okay. So there is another chunk is overlap with this. There is a connection between two, right? That is overlap. What we given here as, I think that is 200. 200. So why we are doing this is because we find this is the first line of the document and these is the second line. These two things are connected to understand LLM to understand that we are having these two variables. And we have a recursive character text splitter, as I said before, which is going to split in character wise 1000 character and overlap would be 200. And we have a len function here and it's just separated by this, okay. Even if it is completed with the some sentence, okay, it like the 1000 word is completed by separate or okay, it was completed like that, it will complete with the full word, okay. So this is a separator for that. Once the space or a full stop or a para while wordly, it would stop, not divide the word into two of, okay. So once you initialize this, we have a load and split function in document loader. What it is do is we load our document. This is one LangChain library, DOCX loader, where you are giving your file path. Here it's loaded. So once it is loaded, you can get the metadata. I'm just getting a metadata here, only the source name and file name, okay. I'm not getting many things here. So once you loaded, it is chunked. Okay, once you chunked, you have to there is a function named split text document, right? This is going to use that recursive character text splitter and going to split the document. And we have load multiple docx. So it loop one by one file and it going to split and add the document in document. What we doing next is once you get the document, you are adding to vector store. So vector store here we can see which is already initialized with the collection name and the directory and the embedding also done, right? So once you add the document in the vector store, the embedding part was automatically done. Okay, add document embedding part will automatically done. So self vector store dot add document, you are adding the document. Here there would be a lot of chunks and everything, so I'm doing it in batch wise. Batch size default is 100, default is 100. Here I'm doing 100 by 100 like that. So next is similarity search. Okay, as I said that Chroma DB is come with that similarity search. We have already embedded our data and stored. So what the part was done here now is we had our document. We have our documents, right? This is our documents, and this document is chunked to small documents, right? Small documents which has a chunk size of 1000 and overlap as a 200 character. Now what we these chunks is stored into our vector db, right? Before that what happened was we delete this. Before we are storing our embedding, right? So how it is stored? Okay, so what has happened before that is these is a consider these is a word. Hello world. Okay, this word is converted into embedding. Okay, it must be a list of point numbers. Okay, 4.4, 5.5 to represent these are all represent these hello world. Okay, that embedding value was stored in vector db. Okay, now once you add the document, right? You added the document got indexed. That's it. This is our document indexing part. That's it. So it's the vector store information is display here. I'm not adding many metadata, so it is not. Next thing is a code generation part. This is the main part. So when you scroll down a little more bit, there is a code generation page. Okay, where you have a header and markdown, and we have initializing the rag as before, and Yeah, checking that vector session store is still there, and you are cutting the collection info, and you are saying that no document indexed yet, or please the index or go to document index page is uploaded like that. So we have our text query box, this part. Okay. If not, generate the code snippet based on the indexed document. If not, this is won't be here. Go to document index and print something here. That would be here. So we have our create box and everything. So what we going to do is I'm not going to explain this part much. We have our generate box and we have our show source document, number of source document to select and generate code. So this is a button. Now we have a show source document has been clicked and number of source document to show that was there. And now once you click that button, what first the spinner will load, then I have to generate our code, right? Go to this. Oh, this is not. This is just that a print statement, okay, guys. When you generate, there is some code snippet would occur, right? That one, and now there is function. Sorry, here it is. Sorry. Once here we have a generate code, right? Generate code query. Once you click, this is happening, right? So go to code generator. This is our generate code function. What this do is first we have initialized a queue chain, rank chain, right? This the we pass our query to this rank chain. Okay. Okay, we come to this generate code part. Now we are calling our QA chain. Before that, these stuffs I have to explain about this. So we go to vector store. First, we are defining what is similarity search. Okay, similarity search. We are it. I'm as actually said before. Chroma DB is come with similarity search. We have setting with the for example, it take here top 4 relevant data. It take now we should add our score with that, so we adding a score. Next part we should add that as a retriever the search type and the quarks you have added here. Okay, you are using that in this QA chain part. Okay. hmm. Here you are using that part. And for this part, I will explain you guys what it is happening behind. First, as I said before, this vector store is using a similarity search. What we use is uh, look, consider the first step would be some similarity search. like cosine similarity search. Okay. Some spelling mistake. Whatever. Similarity search. So first thing that your RAG pipeline do. The next thing is going to get that top 5 relevant data. Okay. So we have used a chain type named stuff, right? So that is going to do combine all the relevant extracted data, relevant chunks into one prompt. Okay, this is going to combine everything into one prompt and we get our final answer. Okay, so this is what is happening. We send our enhanced query, right? So we send our query. First part, we send our query uh, and find our similarity thing. Okay, when here you are getting the final answer, right? Which is how what you are getting is this combined prompt is sending to LLM. Okay, it's sending to LLM and that LLM is give you this answer. Okay. So those all part you would do in that one single pipeline here. Okay. So once you get the answer, it will displayed here. Okay. So for example, as I'm showing you one again, create agent in Python using Microsoft Agent Framework. Okay. Generate code. I have ticked that show source document, right? I will show you something. Here is our answer, right? It's creating a simple agent. We in the end we have our source document, right? Here you can see that page URL, the title, actual so page is that it is taken to find this answer. So here it is showing up to 5. So which is you have mentioned here number of the source document to display. If you change to 10, it will display the 10 document that which is referred. Okay. So that's all about guys today. I hope this is understandable. I will add this code in my GitHub and add the link in the description. If you guys find this video interesting, please subscribe my channel and really press the like button. Thank you for watching if you watched it till now.